Hello, calculus students. Welcome to another online lesson. We'll be continuing our discussion of statistics from last class and looking at frequency tables, using technology to find mean, median, and mode. Also estimating mean, median, and the modal class when we have continuous data, and defining cumulative frequencies. Start off with a few definitions. When we have a frequency table, these may include other columns showing the following. You've got relative frequency. Well, the word relative has the root of relate. And if we're relating to something, we're putting it in context. For example, if I say I have 5 of something, that might not seem like that much, but when I compare it to other people who only have 2, everybody else, then it seems like I have a lot compared to them. And so that's the idea of relative frequency. We're comparing it to something to put it in context. So if it says relative frequency, we've talked about this back in probability, we express it as a fraction of the total frequency. So you put the total frequency in the denominator, the total number of things that we have, and the thing that we're talking about in the numerator, just like you would if you were creating a probability, and we call that relative frequency. Cumulative frequency is a running total of all your frequencies. So you just add them up and keep increasing as you go along. And then cumulative relative frequency puts those two previous ones together where you have a running total of your relative frequencies. So your total will always end up being one whole because you have all these fractions that have been totaled up. And we'll take a look at those in just a moment. But before that, I want to give you a little bit more in terms of notation. When talking about median, which was one of the focuses of our class last lesson, when we have a large group of data, you don't want to do that sort of old school mechanic that we used. Like, let's say I've got the numbers 1, 4, 7, and 9. And if I was asked to find the median back in the day, a lot of us would have just marked things off from the left and the right to find the median in the middle. But what happens when you've got, 73 numbers, or you've got 80 numbers, or 2,000 numbers? You don't want to have to write out all 2,000 and mark them down. We want to know exactly where that number is. So if we have an odd number of scores, for example, this example I just did here had an odd number of scores. There were 5 of them. We divide the number of scores, 5, divided by 2, and then we round up. 5 divided by 2 is 2.5. If I round up to the nearest number, I get 3. And we can see here that the median was the third term. Here would be our first term, our second term, and then our third term out of the 5. Well, that also works if you have a much bigger one. Like, let's say I had 75 numbers. I divide 75 by 2, and I'm left with 37.5, which rounds to be 38. And so whatever the 38th number is in the row, that is my median. And that way I don't have to do all those slashes and write out all those numbers. Now, what happens if we have an even number of scores? Well, let me give you an example. Let's say I just had 1, 3, 6, 9, 11, and 12. I've got 6 numbers there. As we know, if we did it the old school way, we could cross them out until we get to the middle. There's 2 numbers that I need to look at, and then I would average those 2 numbers together to find my median. Well, that's the same idea that we'll have here. Notice we had 6 numbers there, 6 different scores or values, pieces of data. We divide by 2, and we get 3. We'll use that term and the one after it. So we're going to look for the third and the fourth term. So the first term was a 1. That's not what I wanted. Second term was a 3. But I want the third, which was a 6, and the fourth term, which is a 9, and I average those together. So let's look at a bigger example. Let's say I had 100 terms. I divide by 2. Where is my median located? Well, it's even, so there'll be 2 of them. 100 divided by 2 gives me 50, and then the one after that is 51. I take those terms and I average them together, and that way I don't have to do all that slashing. So let's take these 2 slides and put them all together here now. Find the mean, median, and mode of the following data. Now, before I do that, I first just want to review those other terms that we had. So we have frequency, but we also have cumulative frequency. I'll make another box for that. So the cumulative frequency is the running total. I have 5 different values I can have here, 0, 1, 2, 3, and 4, but I have multiples of those. I have 12 zeros, for example. So if I listed all these numbers out in order, I'd have 0, 0, 0, 0, so on and so forth. I'd have 12 of those. And then I would start listing my ones, and I have 17 of those, and so on and so forth. So a lot of numbers. If I do a cumulative frequency, it means keep a running total of how many numbers we have. So to start with, we had 12 zeros. So I had 12 numbers to start with for my first row. Now I have 17 ones. Well, 12 plus that 17 gets me up to 29. So I'm now up to 29 numbers that I've looked at. They've all been ones and zeros. And now I add on the 22 that I had, which were all twos. And so I'm now up to, 51, I'm sorry. 51. And then I add nothing to that, and I'm still at 51. And then I add 4 more to that, and I'm up to 55. So 55 pieces of data here in total. And so that's cumulative frequency. How many numbers were a 2 or less? Well, I can look right here. 51 numbers were 2 or less. How many numbers did I have in total? 55. So lots of things I can do there. This can also be helpful when I'm looking for my median. Last slide, I said that we could find the middle numbers very easily by dividing by 2. Well, we had 55 total numbers. I got that right here from my last value of my cumulative frequency. I divide by 2. I'm left with 27.5, which rounds up to 28. And I want the one after. No, wait, I'm sorry. I just want that one because it's an odd number of terms. There were 55 of them, so there will be one right in the middle. So I'm looking for the 28th term. Well, the first 12 terms, those were all zeros. Again, if I wrote out the first 12 numbers in this list, they would all be zeros. I don't want the 12th term. I want the 28th term. Now, the next 17 numbers were all ones. And how many numbers have I looked at if I've looked at all the zeros and all the ones? 29 numbers. Well, I'm looking for the 28th number. And so if the first 12 numbers were all zeros and the next 17 numbers were all ones, and I've now looked at 29 numbers, the 28th term must have been a 1. So my median in this case would be 1. And I use the cumulative frequency to help me do that instead of having to write out all the numbers and cross them out until I get to the middle. We also had vocabulary dealing with, relative frequency. I can demonstrate that right here. So relative frequency, we take our numbers or our frequencies and divide them by the total. So our first frequency was 12, and I just put that over 55. So I had 12 out of 55, and then I had 17 over 55, and then 22 over 55, and then 0 over 55. You could put 0 over 55, or you could just put 0, and then finally 4 over 55. And then last but not least is our cumulative relative frequency. I don't have enough room to write that all out, so I'll just abbreviate here. And that would be a running total of my relative frequencies. So I can do this 2 ways. I can either start adding up my relative frequencies, like 12 over 55, and then add on the next one, which is 17 over 55, giving me 29 over 55. Or I can just take the cumulative frequency values and put those all over 55. So I had 12 over 55, then 29 over 55, then 51 over 55, and again 51 over 55, and then finally 55 over 55, also known as 1 whole. So those are examples of other things that we can do to organize our data. The most useful of which is this cumulative frequency, which we use to help find the median. We can also now find the mean of our data here. And for the mean, what we do is we add up all of our numbers. Well, again, we have 55 numbers. I don't really want to add up all 55, and that's why thousands of years ago someone invented multiplication. So we have a bunch of zeros getting added up. How many? 12. So 12 times 0. So I'm using my frequency along with my data. So 12 zeros, plus we had 17 ones, plus we had 22 twos, 3 zeros out of room, so I'll add it on over here, and then I had 4 fours. How many numbers total? We had 55. And so I can simplify the numerator. That's a 0, so that's gone. That's a 0. 4 times 4 is 16, plus 17 gets me up to 33, plus another 44 gets me to 77. So 77 over 55. And I simply divide those. And I end up with a value of 1.4 being my mean. Often mean will be abbreviated with an X with a line over it. So we can say that the mean X with a line over it data is 1.4. Last but not least is the mode. We need the mode of the following data. So the mode is the one that occurs most often. Again, we have 0s, 1s, 2s, 3s, and 4s. Which one occurred the most often? Well, whichever one has the highest frequency. The frequency that's the highest is 22. Which data did that go with? It was 2. So our mode is 2. That's a nice easy one. So our mean was 1.4, our median was 1, our mode was 2. Now, part of the learning intention for today was I also wanted to show you how to use technology. And I didn't just mean so that you could add things up using your calculator, but rather get some money's worth out of this expensive machine that we have here. So what we're going to do is we are going to go to a menu called Stat on our calculator. It's right dead center in the calculator, just to the left of the left cursor. And we are going to go to Edit. So Stat, so you have to press right in the center, and then we went to Edit to get some data in our calculator. You'll notice I already have some data in my list here. I would like to clear it. In order to do that, I go to the very top where the L1 is highlighted now. I press Clear, and I press Enter, and it's all gone. If you press Delete, your list will actually go away, and you'll need to come see me, and I can tell you how to get that back. But press Clear, and then everything's gone. I have two lists. The first one contains, 0, and then 1, and then 2, and 3, and 4. And my second list contains 12, and 17, and 22, 0, and 4. Once you've got your data entered, we go back to our Stat menu, but this time we're not editing our data. We are going to calculate. And we ask ourselves, well, we've got two options here right at the beginning, one variable stats, or one var stats, and then two variable stats, or two var stats, which stands for two variable statistics. How many variables do we have? Well, we have a score, and then we have frequency. Is frequency a variable? The answer is no. That just counts up how many of each of those pieces of data or scores we have so far. So we only have one variable statistics. So we select 1 on our calculator. And if I just press Enter right now, the calculator will assume that since we are doing one variable stats, that it should look at one list of data. And it will automatically look at list 1. And if it only looks at list 1, you'll notice here that we see some familiar things. We've got our mean, X with a line over it, is 2. That doesn't seem right. I thought we had like 1.4. And then you've got some other stuff that we'll talk about on a later class. And then we go down here, N. N stands for the number of terms, and that's where I really see that we have a problem because it's only looking at 5 terms, which means that it was only looking at our first list. I don't want the calculator to only look at the first list. I want it to look at both lists and specifically note the second one is a frequency list. So let's go back to the drawing board. Clear this out. Our data has already been entered, so we go to Stat, calculate one variable stats again, but we need to tell the calculator to look somewhere besides just list 1. Again, one variable stats, it'll automatically look at list 1, but we put our data in 2 lists. The first list is always your data list, and I'm going to tell it that it's L1. The way I got that was pressing the second key and then the number 1. And then I'm going to put a comma in, which is right above the 7. And now I'm going to tell the calculator where my frequency list is. If you tell the calculator about a second list on one variable stats, it knows that it can't be more data because you already told it it's only one variable. So it will know that my second list is my frequency list. So I press second and then the number 2. So one variable stats, L1, comma L2. If you have an updated operating system, it will actually just ask you for where your lists are. It's a little bit more user-friendly, but on the old school calculators, which most of you have, This is what it'll do. Now we press enter, and these values look a lot better. I noticed that there's the mean right at the beginning, x with a line over it. That's 1.4. I know that there are 55 terms, which you saw off our cumulative frequency. I said I'd talk about this later, but we've got this Greek symbol sigma, which always means sum. X represents our data, and if we add up all of our data, we have 77, and we saw that when we calculated the mean. Also, you can arrow down using the cursor, and it gives us some more data, like our minimum value being 0, our max value being 4. That was our highest piece of data. And then you see MED, which is our median, and that was 1, which is what we calculated early on there. So using technology to find mean, median, mode, even with a frequency table. Now, what happens if our data is not discrete? Continuous data, we group into classes. We talked about this a little bit last time. In order to get a class into a calculator or to average using mean or even finding a median value or something like that, we need to represent each class with a value. And we call this value the midpoint because it lies right in the middle of each class. The midpoint of the class interval is an average of its endpoints. So whatever you have as far as your class, meaning if you go from 0 to 10, you average the 0 and the 10 to get 5 as your midpoint. Any data calculated using this midpoint is an approximation. It's a rounded value of the true value because we don't know all the actual values. And then the mode of continuous group data is called the modal class. We don't actually use the midpoint for that. We just say which class occurs the most. So let's take a look at those. So here I've got a list of data that is grouped data, continuous data, and we have scores that go from 0 to 10, and then from 10 to 20, 20 to 30, so on and so forth, and then frequencies that go with that. So that means I have 2 values that lie somewhere between 0 and 10. I have 8 values that lie somewhere between 50 and 60. 5 values that lie between 90 and 100, so on and so forth. This time I'm going to cut straight to the chase and use my calculator right away. I'm going to enter in my data. Again, go Stat, Edit, highlight my list, clear it out, so I can put my fresh data in. Now, for my first column, I can't put in 0 to 10. I need to actually approximate that, and again, we're going to use the midpoint. The average, meaning mean, of 0 and 10, if I add them together, I get 10 divided by 2 is 5. So my first data I'm going to use is 5 to represent those values from 0 to 10, and then 15, and 25, and 35, so on and so forth. Again, this will give us an approximation of our mean. We don't want to use just the high value or the low value because that would skew our data in one direction or the other. We enter in our frequencies into list 2, which saves us some time from having to enter in every single value multiple times, which we would do if we made just a single list. And once we are done with this, we follow the exact same steps as before. We go to Stat. We go to Calculate, one variable stats. Again, we tell the calculator L1, comma, L2, because that's where our data and our frequency list is. Press Enter. And we see that we have a mean of approximately 62.3. 64 pieces of data, a mean of 62.3. Now, I don't want the median off this because I want instead, we could talk about what class the median lies in, or we can talk about the mode, but I don't actually need my calculator to do any of those things. So I will put the calculator away for now. The modal class is the class that has the most stuff in it, and the highest frequency we see here is 17. So my modal class would be 70 to 80. And again, we said that mean was that 62 and change value. One last example. We can also make a graph called a cumulative frequency curve. It's a graph that represents cumulative frequencies. They're plotted against the upper end of each class interval. If you want to find the median using a cumulative frequency graph, you simply find the 50th percentile and then use the graph from that point on. So let me give some examples of that. So I have what is known as a cumulative frequency graph here. It says the graph below shows the cumulative frequency of yearly incomes for 200 people. I'm going to scroll just a little bit so I can see all my questions there. So let's just talk about the graph for a second. 20 people, 40 people, 60, so on and so forth, all these different values here represent how many people are involved in the study. There were clearly 200 people because that's where my graph ends. I could start with the data and say how many people made 50,000 British pounds or less. I'm sorry, 5,000 British pounds or less. And I can follow the 5,000 up to the graph, go over, and I can see there were 20 people who made 5,000 or less British pounds per year. If I wanted to do 30,000, I could follow that up here, go straight across, and I can see that about 190 people made 30,000 or less. And that's how this thing works. If I want to just find the values that make between 5,000 and 10,000, I can follow the graph up for 10,000, which is about 60. There were about 20 for 5,000. So 60 people made 10,000 or less. 20 people made 5,000 or less. So how many people made between 5,000 and 10,000? I could take this 60 and the 20 and subtract. And there are approximately 40 people in this range from 5,000 to 10,000 that made that amount of money. So this is a cumulative frequency graph. Now we're going to use that to answer some questions. You'll notice pretty much every time I answer a question using this thing, I end up drawing on the graph. The percent of people who earn less than 5,000 British pounds per year. Well, we just talked about that. I find my 5,000, followed up to the graph. There were 20 people. So 20 people made less than 5,000 British pounds per year, but they're asking for the percent of people. To make a percent, we divide by the total. We know that there were 200 people in total. Said so at the beginning as well. And so that becomes 0.1 or 10% of our population made 5,000 British pounds or less. Now it asks for the median. Well, we have 200 people in this study. If I listed them all, put them in a line from the smallest earner to the largest earner, where would the median be? It would be right in the middle, around the 100th piece of data. So I take that 100, I follow it over to see what actual income that 100th person would have made, and it's about 15,000 pounds. Great British pounds. And the lowest income of the richest 20% of this group. Richest 20%. Well, we have 200 people. How much is 20% of 200 people? We'll take 0.2 or 0.20 for your 20% times the 200, and we end up with 40 people. So there's 40 people that are the richest 20% of the group. But if I just go up 40 on my graph, 40 people here, and then follow it down, that's not the richest 40 people. Those would be the poorest 40 people. So the richest 40 people, the easiest way to do that would be take 200, subtract 40. So everybody is 160 and higher would be the top 20%. So the 160th person and above. So I follow from 160 until I hit the graph, bring it straight down, and in between 20 and 25,000, but not smack dab in the middle. So approximately, we could say maybe 23,000. That's the income of the lowest income of the top 20%. So anyone who's making 23,000 or more would be in that top 20%. And this is a cumulative frequency graph. In the book, we have a couple of problems dealing with each of these. 513, 1 and 3, 517, 2 and 3, and 529, 3 and 5.